Good afternoon, Year 4, and welcome to the second part of our science lesson. So, last lesson we started focusing on a new topic, which was states of matter. Okay, and what we're going to be doing this lesson is continuing that flow. So, do you remember what states of matter were? Can anyone explain? So have a think, what did we do last lesson? What were the three different states of matter? So what we're doing today then is we're going to be continuing to compare and group materials together as solids, liquids, gases. Now, in order to continue with our lesson, first of all, I'm going to recap what the difference is between the three states of matter. So I'd like you to watch the following video. Okay, listen carefully.
All right, guys, what have you got there? You've each got one of the three states of matter: solids, liquids, and gases. Solids, like this block of ice or this ball, retain their shape and volume. You can hold them and cut them into pieces, and they always take up the same amount of space. Liquids, like water or honey, can flow or be poured, and they're pretty tricky to hold. They change shape depending on the container, but always keep the same volume. Gases are crazy and don't keep their shape or volume. They spread out and can fit any container they're put in. Often you can't even see them. Gas is put into some drinks to make them fizzy, and when we drink them, that gas can sometimes try to escape from our bodies. Oh, delightful.
Okay, so now we know the difference between the three states of matter, between a solid, liquid, and a gas. What I'd like you to do now is to classify the following. So you can see an ice cube, some water, and some steam escaping from the iron. So I'd like you to classify them. Which one is solid, which one is a liquid, and which one is a gas. So pause that while you work it out, and then we'll go through the answers together. So well done then if you recognise that the ice was a solid, the water is a liquid, and the steam is a gas. What I'd like you to do now is to convince me that an item can change shape. So something can change from being a liquid into a solid, or from a liquid into a gas. So have a look and see if you can explain the process using the word bank that I've provided to help you. So on our word bank, we've got solid, liquid, gas, particle, evaporate, evaporation, condense, condensation, melting, freezing, change, state, water cycle, cooling, heating, and temperature. Now, you don't need to use all of these words. This scientific vocabulary will help you when you are trying to explain the process. So can you convince me that an item can change state? So well done then if you recognise that water can change from a liquid to a solid in the process of freezing. So remember, once a temperature has fallen to 0 degrees, that is freezing point. And at this point, water changes from a liquid to become a solid. But if we increase the temperature, so we make it warmer, the ice then starts to melt. And when it melts, it stops being a solid and it becomes a liquid again. Now, to change water to steam, how can we do that? So have a think about what happens at home at tea time. You might see some pots and pans on the stove with water in, and you'll notice water vapour, so steam, escaping from those pans. And in this instance, water is changing from a liquid into a gas. It's becoming steam. So temperature often affects how an item can change state. So I want you to show me an example of a reversible material. So this is an item that can change its original state and then change back again. So for example, as we just discussed, water can turn to ice by freezing, and then it melts and turns back into water. This is an example of a reversible material. It can change and change back. So pause this while you have a think of some reversible materials. And when you're ready, press play and we'll go through some ideas. So if you think of a candle, wax, it's a solid, but once it's heated, that wax then turns to liquid. But when we cool that wax, so when there's no heat on it, it will solidify, it will change back to a solid. Another example then is a freeze pop or a tip top. Okay, so if you think about them when you buy them from the supermarket, they're a liquid. But once you pop them into the freezer, they freeze and become a solid. But if you get that tip top out and leave it on the side in a room, it won't stay frozen, it will become a liquid again. And chocolate. So if you were to heat chocolate, it will melt, but once you stop applying heat to it, it will solidify, it will become a solid again. So these are 3 examples of reversible materials. What I'd like to do now is to show me an example of an irreversible material. So this is an item that cannot change back to its original state once it's been altered. So think about, for instance, baking a cake. If you bake a cake, you add all your ingredients together and mix it up and pop it in the oven. But once it's cooked, you can't then take that cake out and separate it back into milk and flour and eggs and sugar. So this is an example of an irreversible material. So pause this while you have a think. And let's think about some different materials then that once they've been altered, they cannot change back. Okay, let's go through some answers. So for instance, if you think of an egg, once you have cooked an egg, it will never again be a runny liquid. It will always be a solid. So whether you fry it or boil it or poach it or scramble it, it will remain a solid. It will never go back to being the liquid egg that was inside the shell. Another example then of an irreversible material then is bread. So once you pop the bread in the toaster and cook it, it will remain toast. It can't go back to being bread. Even though it's still a solid, you can't change its state back to its original form. And another example then is fire. So if you think about, for instance, a log of wood or a piece of paper, once it's been burnt, it's never going to be the same as it was before. So this is an example of an irreversible change as well. So let's move on. Dr. Spartacus says that fizzy drinks such as Coca-Cola are liquids and gases. Is he correct? I'd like you to have a go explaining your reasoning. So pause the video while you have a think. So fizzy drinks such as Coca-Cola are liquids and gases. Is Dr. Spartacus correct? Explain your reasoning. So what did you think? I thought back to the video that we watched at the start of the lesson where one of the characters drank the liquid. So he was drinking a fizzy drink then. Was it just a liquid or was it a liquid and a gas? How do we know? So he was correct because fizzy drinks such as Coca-Cola are liquids and gases. Because they're fizzy, the fizz in your drinks is made by tiny little air bubbles, which are balls of gas. Okay, so if you drink lots and lots of fizzy pop, okay, what often happens? We saw it happen to the character in the video. All of that gas builds up and has to be expelled, which often happens in the form of a burp. So when somebody burps, liquid doesn't come out of their mouth, does it? It's gas. So Dr. Spartacus is correct. Fizzy drinks such as Coca-Cola are both liquids and gases. So your task then, what I'd like you to do at home is create a video explaining what the 3 states of matter are and how we can change a material from one state into another. So I'd like you to include an example of a reversible and irreversible change to demonstrate your understanding. So you can do this at home as an experiment. You can, with an adult's guidance, film yourself frying an egg to show that it's gone from being a liquid to a solid. Okay, so use the word bank below to help you with your explanation, but have a go at thinking of some real life examples of reversible and irreversible changes. So where we can change an object from a liquid to a solid, or a solid to a liquid, or a liquid to a gas. Okay, I'd like you to have a go at showing me an example with an adult supervision, please. So create a video explaining what the 3 states of matter are and how we can change a material from one state to another. If you can, try and give me some real life examples and use the word bank below to help you with your explanation of each process. Okay, so well done, everybody. Looking forward to seeing what you produce, looking forward to seeing your explanations. Remember, if you get stuck or you're a bit confused or you need a bit of help, go back, revisit different aspects of the video, different points to help you to develop your understanding. You've got the word bank there ready for you if you need to use it. Okay, so remember, this lesson goes at your pace. If you need a bit more help, it's here for you to revisit the different sections. Okay, so thank you very much for tuning in to Science, and I will see you all next week in school. So you can give me big waves and big smiles then. Okay, see you all later. Bye.